Okay, so we've been talking about potential energy, and we talked about how potential energy is different from kinetic because kinetic, the object is in motion. Work is currently being done. A force is applied, and the object moves a distance. Okay, potential energy is different though. We talked about potential energy is energy an object has because of its position. Okay, so yesterday we talked about gravitational potential energy, and we talked about how gravitational potential energy has two factors. Those would be mass and height. The more mass an object has, the more potential energy. The higher you raise it in the gravitational field, the more potential energy. All right, today we're going to talk about two. First one we're going to talk about is elastic energy. Okay, then we're going to talk about magnetic. And actually, when we go over it, you'll see how both of them are really kind of similar to each other. Okay, and they kind of act the same. So elastic energy stored as a result of applying a force to deform an elastic object, okay? And there's two ways that we can kind of deform an object. We can either stretch it or we can compress it, okay? So I have two really simple examples here. I have a rubber band. Right now, the rubber band's position, it doesn't have any elastic energy because the way it's positioned, it is not stretched, okay? So if I just simply stretch it, now we have a bunch of energy stored in this rubber band and it has the potential to do work because of its position. I've stretched it. I've stored energy into the rubber band, okay? And that energy is going to stay there until one of two things happen. I let go or the rubber band breaks, all right? So when I let go, all that stored potential energy, because of the way it's positioned, I've stretched it, gets released, okay? So we can stretch things. When we stretch things, we store energy in them, all right? The other way we can do that, we can have elastic energy, is by compressing things. So this is probably maybe hard to see. This is a spring, okay? It's the same spring that you'll find in most of your pens, okay? So this is another example of elastic energy. When you click your little end of your pen, it makes the spring compress, and we're storing energy in that spring. So when I click, I've got energy stored in that spring. When I click again, it will release the energy. Okay, so that energy is stored there. This spring inside there has been compressed. It's hard to compress it outside, but we've smushed it. Okay, we've compressed it, and energy gets stored there. And that energy is going to stay there until we release it. We release it by clicking it again, and you'll see that the pen will then move. It'll jump. So you can see we store it, release it. Store it, release it. Let's see if I can get a good one. Okay. So a couple examples of this. We talked about in the last video, pole vault and a bow and arrow. All right, so we're going to look at a couple videos here really quick of a bow and arrow. All right, so I want you to watch as the archer pulls back the string. Most people think the string is what stretches. The string doesn't stretch. What stretches is the bow. So this is in a recurve bow, not a compound bow. So when he pulls this string back, you'll see that the ends of the bow will move. So let me kind of trace this here. Trace this. All right, so he's pulled the string back, and it's probably hard to see. I'm going to go ahead and trace the bow again. So you can see, here was position 1, and position 2. At position 1, the bow's up here. At position 2, the bow flexes back. the ends of the bow actually get closer together. So we're compressing the bow. And when we let go, the bow flexes back and it shoots the arrow. All right? So a recurved bow is a really good example of elastic energy. On a recurved bow, the harder or the farther back you pull, the more potential energy you store in it. Okay? So the farther back he draws the string, the more potential energy it has. Another good example of elastic energy is pole vault. So, here we have a slow motion video. So the vaulter, he's ran down the aisle. He's ran down the lane. Okay? So he's got kinetic energy. He's going to put this pole in what they call the plant box. And it's going to stop the pole. And you'll see right now, the pole is perfectly straight, right? Perfectly straight. So as he keeps running, that pole is going to bend. So let's watch. All right, right there. So the ends of the pole, they got closer together. They kind of bent. So we get this big bend in here. So we've compressed the ends of the pole. So kinetic energy, he plants, all that kinetic energy he had is now getting stored in the flex of the pole. So he's now going to lift his feet, and that pole's going to unflex, and it's going to shoot him up. So now you can see the pole straight again. So all that energy he stored in the pole is now getting put back into him, and it's shooting him up. So what he's done essentially is taken his kinetic energy going this way, stored it in the pole as it got bent, and then released all that potential energy back into kinetic in another direction. Okay? So elastic energy is when you compress or stretch or rarefact something. You're storing energy in it because of its position. Okay? So let's look now at magnetic energy. Magnetic energy, an object that has potential to do work because of its position in a magnetic field. So, I ordered some magnets, and they came in last night, and Mr. Alt already broke 2 of them. These are really strong magnets. In fact, I don't know if you can see, last night 2 of them kind of came together on my thumb and actually busted my thumb open. So they're really strong, so I have to kind of be a little bit careful here, okay? So these are what they call rare earth magnets, and the atoms inside of them will easily be manipulated. And what I mean by that is all of the electrons in these kind of go to the same side. All right, so we have all the atoms. Think of all the atoms in here, and they're all together. And just think if all the electrons went to the same side of the atom, we would have all the negatives this side and all the positives on this side. So we're making a magnet. That's how magnets are formed, okay? So magnetic energy is energy an object has because it's in a magnetic field. It's positioned in the magnetic field. Magnetics work a lot like elastic energy. Like poles. So if you have a north-north or a south-south alignment, to increase potential energy, you compress them. So I have here one of my magnets, and it's got it's like a donut. So I'm gonna put it on this wooden skewer here. Okay, and I'm going to do alike poles. So the way I know they're alike poles is one side, I don't know if you can see, one side's like completely flat and the other side has like a little divot in it. So I know the flat sides are one pole and the divot's another. So I'm going to make these go and make those little divots align. So you can see the magnets are holding each other up. They're pushing each other away. Okay? There's energy stored there. Now, if I want to increase the amount of potential energy, I'm going to change their position. I'm going to put them closer together. I'm pushing just about as hard as I can. I can't make them touch. Now, if I would let go, this magnet would shoot way off the skewer, but these are pretty brittle. I don't want to do that. They'll break, okay, and they're pretty expensive. But you can see if I compress them, you can see how it bounces like a spring. So I compress it, it bounces. Compress it, it bounces. Okay? So alike poles, just think of it like a spring. The more I compress it, the more energy I put in it. Like I said, if I really compress this and let it go, this would just go flying off. Okay? Now, opposite poles can be stretched with the magnetic field to increase. So it's like a rubber band. Remember the rubber band I stretched because of its position? When it was relaxed, it didn't have any potential energy. But when I stretched it, I changed its position. Just like the bow, I stretched it, I changed its position. All right, so when you have alike poles, so here's one of the magnets I broke. When you have alike poles, they stick together. All right, so when I pull them apart, I'm storing potential energy in it. So let me fix the camera here so you guys can see this. Okay. So you can see I have my two magnets up there. They're hard to see. Let's put them on some white paper. There we go. That's a little bit better. All right, and you can see once I position them in the magnetic field and they get close enough, you'll see them come back together. All right, let's do that again. So they're together. I stretch them apart just like a rubber band, and they go back together. Oh, they broke again. That's all right. Now they're really hard to get apart. So I stretch them apart like a rubber band. They're stretched apart. And then once they get close enough, you can see they go back together. Okay? So, elastic energy, when we compress or smush something, or we stretch or rarefact something, we store energy in it. Magnets work very similar. Alike poles are like a spring. You compress them. Opposite poles are like a rubber band. You stretch them. Okay? So keep that in mind when you're doing your worksheet. Okay? If you guys have any questions or you need help with anything, be sure to get a hold of me.